Day homework from the parabolas where the first 5 questions are matching. So you have a graph, you're going to match it with the equation. And then the second 5 questions are writing the equation in standard form, finding the parts of the ellipse, and then graphing the ellipse. So 5 problems that you have to do a good bit of work for. And then the first 5, kind of like a little bit of work, understanding that the information creates that specific ellipse. So looking at our definition, an ellipse starts off with the set of all points, which is how every single conic starts. That's that locus. So every conic has the set of all points. And then they have to meet a condition, a geometrical condition. And this condition says the sum of whose distances from 2 distinct fixed points, called the foci, is constant. So remember a parabola. A parabola exists because anywhere on the parabola, the distance from the focus to the parabola or the distance from the directrix to the parabola is the same. An ellipse, the specific geometrical property, it says the sum of whose distances from 2 distinct fixed points is constant. So now we have 2 points, and the sum of those distances wherever they are on the ellipse is the same. I'm going to draw a little diagram above the definition, just so you get an idea of what it's going to look like. And then we'll draw 2 specific graphs underneath and that are a little more precise. So there is some space up above, just so that we can kind of see what we're talking about. So we have an elliptical shape, which is kind of like oval. So think if you have an oval mirror in your bathroom or your hallway, or maybe your grandparents have an old ornate oval mirror. So this is saying the sum of whose distances from 2 distinct fixed points. Distinct means they're separate from each other. Fixed means that they're going to be at that same location inside of the ellipse, and they're not moving from inside of the ellipse. So wherever they are, they're fixed inside that ellipse. They're not moving. So if I take the distance from one focus to a point on the edge and the other focus to a point on the edge. If you add those 2 distances together, that's what sum means. That distance should be the same no matter where you are. Sorry, that's sloppy. Where you are on the ellipse. So wherever I am on the edge of the ellipse, the distance to get from one focus to the other, if I add those 2 together, it's going to be the same distance. So anywhere on the edge, take your distance to the focus, add that distance together, and it should be the same every single time. So that's what the geometrical property would be for an ellipse to be created. So as I said, we're going to draw 2 pretty precise graphs. One is going to go horizontally, and then the other one will go vertically. Just like a parabola can go up or down, it can go left or right. And the same thing with the ellipse. So we'll start with the horizontal one. An ellipse has what we call a major axis. The major axis is going to be the longest distance from either left, right, or top, bottom of this oval. So the major axis would be, if it's the longest distance going left and right, then our graph is going to be a horizontal ellipse. So we will make ourselves a fair size ellipse here so that we can plug in a lot of stuff. Wonderful notability. We'll draw a beautiful oval for you. I mean, last year I had to try to draw this thing on the board. Like, I never got a nice one. The smart board doesn't kind of pick up your drawing and make it nice and oval, but the Notability does. So the first thing that we're going to label is our major axis. The major axis is from tip to tip, connecting the entire ellipse together. So from one side to the other of the ellipse, that's called the major axis. And this one is horizontal. Again, that's the longest distance. This graph has a center, like the circle has a center, and that center is going to be in the middle on the major axis. The center is H and K. So the circle has a center of H and K. An ellipse has a center of H and K. So I did say this is kind of like having two parabolas that connect together. So on the end of this ellipse, you will have two vertices. So we will have one vertex on the right and one vertex on the left. So pluralized, they're called vertices. The distance from the center to the vertex, that distance is a distance of A. That A value is going to be in the equation so that we know how wide to graph the ellipse. So to find the vertex of the ellipse, you're going to take the H value and add that distance of A to it. And then I will know where to place my vertex, either on the left or the right. So I would either add or subtract the distance of A to get my two vertices. And you can see underneath, it says the vertices are A units from the center. So the vertices would be that distance adding or subtracting, depending if I'm moving left or right from the center. That tells me how wide my graph is. It also says that the major axis is 2 times A, and the reason it's 2 times A is because A is on the left and the right, so that whole distance would be double A. So the distance of the major axis is that whole distance from vertex to vertex. The second thing underneath, it does say to locate. So the second thing is the minor axis. So if the major axis goes left and right, the minor axis would go up and down. It goes through the center of the graph. So the center truly is the middle of the graph, vertically or horizontally. And we'll label this as our minor axis. It's the smaller of the two. It also tells you that the minor axis, the length is 2 times B. Again, B is going to be in our equation. So A will be in our equation and B will be in the equation. So the distance from the center to the end is B. So that distance is B. So if I double B, then I get the entire minor axis. So that's going to get us like the other, in this case, the height of our ellipse. So we have the width from A, the major axis, the height of it, that vertical distance is the distance of B. There is no special name for these endpoints, wherever they would be, where the minor axis is created. They're not called like subvertices or anything like that. It just gets us the other dimension, in this case, the height of the ellipse. So no fancy name, just the minor axis. And then the last thing that we're going to locate are the foci, F-O-C-I. So focus parabola has a focus. When you pluralize it, you place an I on the end, and it's called a foci. Foci pluralized. Now there are two of them. They are somewhere between the center and the vertex. So they're going to be somewhere between the center and the vertex. And the distance is C units from the center. And the easiest way to remember that, foci has a C in it. So C is the distance from the center to the foci. And I'll put that on the left side here, since I have a lot going on the right. So you can see that there's a ton of stuff up here. We have two vertices, two foci. We also have the height of the ellipse. So I have three letters that we're talking about. We're talking about an A, a B, and a C. The focus is found by subtracting C or adding C. And if this is left or right, we're adding it to the X value. So you're starting at the X value in the center, and then we're adding or subtracting from the center left or right, which is why X is changing, because it's a horizontal graph. My horizontal variable is X. So to summarize a little bit underneath, we have vertices, which can be found by adding or subtracting A. And we have the focus or the foci, and they can be found by adding or subtracting C. You'll be asked to find both of those for every graph. And then, of course, we have the center, which is just H and K. A lot of information for one graph. So A is to get to the vertex. B is the other direction, the opposite direction of the vertex. And C is the distance from the center to the focus. And it's not always going to be in the middle of the center and the vertices. Sometimes it might be close to a vertex. Sometimes it might be closer to the center. Just depends on the numbers that you're given in the equation. So we're going to see if we can take all this information, flip the graph, and make it go up and down. So now we have a vertical major axis. It's a little tilted. Here we go. So see if you can try and label the information, except now it's labeled vertically. So vertical major axis is that longest distance now going up and down. So that longest distance is the major axis. So in the middle, you still have the center. And then at the top, we have one vertex, and at the bottom, we have the other. So because it's going vertical, Your vertex is the distance from the center to a vertex. That distance is A. It's still the same A, except now it's vertical because that A value is going to be a large value, making us go up and down. Your vertex would be K minus A or K plus A, because it's the vertical variable, which is our Y. So to get the vertex, I add A or subtract A from the Y value, because now it's a vertical graph. The minor axis goes through the center and the other way. And that distance is our B. So you can see A is going to be bigger than B. That's going to be what we're looking at when we determine is it vertical or horizontal. So the A is bigger than B. The A is the major axis. The B goes with the minor axis. And then the last thing that we're going to graph are each of those foci values. I should label the minor axis. And each focus is H, K plus C, or K minus C. So again, the focus has a C. It's C distance from the center. So the focus goes with the variable C. So the center is still H and K. The vertices are K plus or minus A. And the foci are K plus or minus C. So vertical, Y is changing if your graph is vertical. Horizontal, X is changing if your graph is horizontal. So those are the two things. Like think about vertical, Y changes. Horizontal, X changes. The last thing that I want to place on here, underneath the foci, there is a little formula that goes along with determining the foci value. And that is A squared minus B squared. A, B, and C are used a lot in different geometrical formulas. So we know A squared plus B squared equals C squared is the Pythagorean theorem. Well, to find this foci value, you're taking A squared minus B squared. So the distance of A minus the distance of B gets you those 2 points that are in the middle of the ellipse. All right. Day one is always the hardest because it's all of this information that you're trying to pull together. And these graphs have a lot of information, lots of parts to them. So the last part before we kind of look at the equation, it says visualize an ellipse by imagining two thumbtacks placed at the foci. If the ends of the fixed length of string are fastened to the thumbtacks and the string is drawn taut, meaning tight, with a pencil, the path traced will be an ellipse. So let's say that I had a string wrapped around this and tied to it. And then the two ends of the string were kind of held using a thumbtack. So I could kind of use my bulletin board over there. But those two ends are connected to a pencil. And as I pull my pencil tight with the string, it's creating this elliptical conic, the elliptical shape. So that's how a conic is created. One of the ways you could kind of think about it. Are we doing okay? I know it's a lot. So there's two equations, of course, that we have to write. And this is the last thing that we kind of have to think about because we need equations in order to figure out how to get all the information. So we have the horizontal equation, just like we did for the parabola. And then we have the vertical equation. Each equation that we do looks slightly different when you're looking at the conics. So recognizing one form versus the other, we'll kind of work on that on Wednesday, because on Wednesday we'll have the circle, the parabola, and the ellipse. So Wednesday we'll summarize all three of them and kind of be able to see like recognizing one form to the other before we add the last conic into it. So horizontal, x minus h squared, y minus k squared equals 1. Kind of looks like a circle. We have these two squared terms. The reason there are two is because it's an enclosed shape. A parabola has one squared term because it's an open shape. There's just one parabola. In the denominator, this is different than a circle. There is an a squared or a b squared. The a is the larger value. The location of the larger value gives you the direction of the graph. So if the larger value is with x, that's when it's horizontal. So you're gonna have to look at your denominator. Wherever the bigger number is, that's your a. So a is bigger. And whatever's in the numerator tells you the direction that it goes. So when you write the standard equation for the vertical graph, it's going to be exactly the same. X minus h squared, y minus k squared equals 1. But a squared is with y. So the location of the bigger number tells you the direction of the ellipse. So larger number, if it's with y, then it's a vertical ellipse. A is always the larger number. That's our major axis. So we're going to look at this example underneath, and we're going to see if we can take the equation and write it in standard form. This is very similar to getting the standard form of a circle. So notice that you have an x squared and a y squared, and then we have an x and a y, and then we have the -8. So to get this in standard form, to have a quantity squared, you're going to complete the square twice. One for x and one for y. If it's not an x or a y, and it's a -8 or a +8 or any number by itself, take that number to the other side. So let's see if we can first get this in standard form. So grouping the information together, I'm going to pull my x's together. And my y's. And then take that 8 to the other side. Notice the x has a 4 with it, so we're going to pull out that 4. Trying to complete the square. The y does not have anything with it, so it's just going to stay as a y squared. So Peter, when you complete the square for the x, what number would you plug into that equation? And then on the other side, you're adding. How about for the y's, Peter? And on the other side, you're also adding 4. So you're completing the square. We're factoring it as a perfect square. So the quantity x minus 1 squared and the quantity y plus 2 squared. And that's equal to 16. So the last part to get this in standard form, if you look at both equations, they're equal to 1. A circle is equal to the radius squared. An ellipse is supposed to be equal to 1. So Darby, what could you do to make this equation equal to 1? So instead of dividing the 4 out, I want this to be 1. So instead of dividing 4, how would I get this left or right side to be 1? Yeah, we're going to divide 16. And we're going to divide each of them by 16. So we want to make it a 1 on the right side. So whatever number's on the right side, you're going to divide the left side by that value. So 4/16 reduces to 4. The other one doesn't have a coefficient, so it just stays as 16. And then this is equal to a big old 1 on that other side. This is the standard form of an ellipse. You have an x squared with a number in the denominator, a y squared with a number in the denominator, and it should be equal to 1. Any questions about getting the standard form of the ellipse? So look at your standard form. Determine the direction of the ellipse. Cool, what direction are we looking at? And it is vertical because excellent. So the 16 is under the y, it's the bigger value. So that means that the 16 is your a squared, the 4 is your b squared. So before we find anything with this ellipse, before we start finding the vertex and the foci, we are going to just list our A, B, and then we're going to see if we can find C. So Cole, if A squared is 16, A would be, and B would be 2. That's the distance from the center to the vertex or the center to the other direction, the minor axis. C squared is A squared minus B squared. That gets me my focus. So A squared is 16, B squared is 4, which is the square root of 12. Or we also know that is 2 square roots of 3. So we have A, we have B, and now I have C. Questions? So the directions want us to find the center, the vertices, and the foci of the ellipse, and then it says sketch the graph. Cole said that this was a vertical. So to find the vertices, your vertical variable is the part that's changing. The vertices are found by using A. To find the foci, remember it has a C in it, they're found by using C. And again, the vertical variable is changing. So Jenny, can you tell me what the center of our graph is going to be? So to find the vertices, you're taking 1 and then -2 plus or minus 4. So Kaden, what would -2 plus or minus 4 give us for our vertices? So that's where our two vertices are. One vertex is at 1, -6 down below. Another vertex is up at 1, +2. The foci are found by taking that same 1 from the center and then -2 plus or minus c, 2 square roots of 3. We're going to keep that exact. So we found the center, we found the vertices, we found the foci. We're going to see if we can finish this off by graphing it. Are there questions? It's a lot of information. So we'll make a little sketch here. And plot a couple of points, or tick marks, I should say. Starting with the center, Jenny said it's at 1, -2. I'm just going to place a little C next to that for the center. Kaden told us one vertex is at 1, -6. And the other vertex is up at 1, 2. You can see they lie on the same vertical line. The distance from the center to the vertex should be 4 because that was A. So I have a distance of 4 up and a distance of 4 down. The focus, it says -2 plus or minus 2 square root of 3. 2 square root of 3 is 12, the square root of 12. The square root of 12 is a little more than 3. We're estimating here. So from your center, go up a little more than 3, and that's where your focus is going to be. From your center, go down a little more than 3, and that's where your focus is going to be. So the distance of C is the square root of 12, which is a little more than 3. Has to be less than 4 because the square root of 16 is 4. So I'm going up to get to my focus and down because everything has to lie vertically. So your focus should be in line with the vertex. The last thing that we have to graph is the other direction, and that's B. B was 2. So my other direction from the center, I'm going left 2 and right 2. Everything's from the center. The vertices, A from the center, the foci, C from the center, and then that other direction is B. So now that we have all of this drawn, see if we can connect this. And then you have your ellipse. Whew, it's a lot. You got 5 of them to do. The first one will take you a little bit of time. The second one will probably be a little less until you get the hang of all that information that you're asked to find. Now, the book is going to use the word eccentricity. We didn't talk about eccentricity. Ignore it. Don't worry about that word eccentricity. We'll talk about that tomorrow. Have a fantastic day. We'll practice these more tomorrow. Tomorrow will be way easier. And if you can just throw your tests on the desk up here, I'd appreciate it.